Transistor. Transistor consists of three sections, three layers made of extrinsic semiconductors. And these three layers are named as emitter, base and collector. The outermost sections will be of same material and the middle section will be of opposite material. PNP transistors, NPN transistors. In PNP, outermost sections are P-type material and the middle section is N-type material. In NPN transistor, outer sections are N-type material and middle section is P-type material. Remember that PNP transistor or NPN transistor can be made of either silicon or of germanium. So we will get silicon transistors of PNP or NPN or germanium transistors of PNP and NPN. So we will get PNP, NPN transistors of silicon and germanium. Because of three layers, two junctions are formed. One junction in between emitter and base, the other junction between base and collector. The junction between emitter and base is known as emitter junction. The junction between collector and base is known as collector junction. So a transistor will have two junctions, emitter junction and collector junction. Generally, collector is larger in size, largest of all, but moderately doped. Emitter is heavily doped, but lesser in size compared to collector. Base is a very thin layer and it is very lightly doped. Base is very thinly doped and collector is moderately doped. Emitter is heavily doped, but the size of collector is large compared to emitter. Base is very thin. A transistor can be considered as though two PN junctions are joined back to back. Symbols used for transistors. Let us take the block diagrams of the two transistors, NPN and PNP. The left top diagram indicates block diagram of NPN. The circles indicate the left and right circles indicate excess of electrons, and the middle part, the circles indicate the holes. So the left part is emitter, the right section is collector, and middle section is base. Now these are represented as follows. We take a circle. Inside the circle there is one horizontal line. It indicates base. At the right there is a horizontal line, indicates collector. At the left the horizontal line indicates emitter. Now an arrow mark is drawn from base to emitter. This indicates the conventional current flows from base to emitter. The conventional current flow takes place from positive to negative. So base must be P-type material. So if base is P-type material, so emitter must be N-type material. So it is NPN transistor. Similarly, PNP transistor, emitter is P-type material, collector is P-type material, and base is N-type material. So the conventional current flows from emitter to base. Hence, an arrow mark is drawn from emitter to base. So if the arrow mark is from emitter to base, it is PNP transistor. If the arrow mark is from base to emitter, it is NPN transistor. The arrow mark will be drawn only in the emitter junction and it indicates the direction of conventional current flow. So based on this, we must be able to identify PNP and NPN transistors. Biasing a transistor. Applying potential difference across a transistor is called biasing it. Since it has got two junctions, we need to bias both the junctions. So we need two sources. One junction is called input junction and the other junction is called output junction. One junction is input junction, the other junction is output junction. Input junction is always forward biased and the output junction is always reverse biased. Input junction is always forward biased, output junction is always reverse biased. This is the principle. A transistor has got three sections. One section should be commonly connected to both the biases. So, depending on this common connection, we give the name to this configuration. So, we have three configurations: common base configuration, common emitter configuration, and common collector configuration. Common base configuration means both the biases will be connected to base. In common emitter configuration, we connect both the biases common to the emitter. In common collector, both the biases should be connected to collector. In common base configuration, emitter junction is input junction. In common emitter configuration, once again, emitter junction is input junction. In the case of common collector configuration, collector junction becomes input junction. Like this, we identify the biasings. See the configurations, figures drawn here. I have taken PNP transistor. The left one indicates common base configuration. The left side line indicates, between P and N line indicates emitter junction. This emitter junction is forward biased. It is input junction. NP junction, right line indicates NP junction, that is output junction, collector junction, that is output junction. Output junction should be reverse biased. So, negative of the battery is connected to P-type material. Take common emitter configuration. In common emitter configuration, PN junction, bottom junction, is emitter junction. So, this is input junction. So, it should be forward biased. So, positive of the battery is connected to P, negative to N. The upper line indicates NP line, that is collector junction. Collector junction is output junction. It should be reverse biased. So, negative of the battery is connected to P and positive is connected to the emitter, common emitter. Next one, third one, the right one. It is common collector configuration. Common collector, in common collector configuration, collector junction is input junction. So, PN, bottommost PN line indicates bottom PN junction, bottom PN junction indicates collector junction. It is forward biased. So, negative of the battery is connected to N, positive of the battery is connected to P. P is collector. The top P indicates emitter. This emitter junction is output junction. So, it should be reverse biased. So, P is connected to negative of the battery and positive is connected to the common terminal collector. Like this, we identify the connections. Working of PNP transistor. Let us take common base configuration. PNP transistor in common base configuration. Let us study its working. A block diagram of PNP transistor is shown. The left one is emitter. It is heavily doped. Collector is lightly doped. Base is moderately doped, of course, with N-type material. Now, emitter junction is forward biased, that is input junction. So, the battery positive is connected to emitter, negative is connected to base. Collector junction is reverse biased. So negative is connected to the P collector and positive is connected to the base. Now this is how bias is applied. Now let us study the working. In this transistor, the holes are the majority carriers. In PNP transistor, holes are the majority carriers. In NPN transistor, electrons are the majority charge carriers. Now let us study the working. Holes in the emitter are repelled by the positive potential of the battery, emitter bias. Due to the positive potential of the emitter bias, holes are repelled towards the emitter junction. And the holes crossing the emitter junction, some of them, a few of them, they combine with the electrons in the base, and thereby a current is constituted in the base. That is base current, IB. Majority of the holes crossing the emitter junction, they will be attracted by the negative potential of the collector junction and cross the collector junction. Majority of the holes entering the base, they cross the collector junction because of the attraction by the negative potential of the collector junction bias. So electrons will flow from this negative potential into this collector, and thereby a current is constituted, that is collector current. As one electron combines with a hole, then because of this combination, a covalent bond will be broken in the emitter. A covalent bond breaks in the emitter, and the electrons, they flow to the battery of the emitter junction. So a current is constituted in the emitter junction. That current is emitter current. Like this, current will flow in this transistor. Briefly, holes in p-type material, emitter, will be repelled by the positive potential and they cross the emitter junction. A few of these holes, they combine with the electrons in the base and a current is constituted in the base, that is base current. Majority of the holes coming into this base, they cross the collector junction and they combine with the electrons that is coming from the bias in the collector, and thereby a current flows in the collector circuit, and that current is collector current. For combination of each electron hole pair, a covalent bond will be broken in the emitter, and thereby electrons will be attracted by the emitter bias and a current flows in the bias, that is emitter current. Working of an NPN transistor. Let us consider common base configuration of an NPN transistor. Here NPN indicates the three sections. The left N indicates the emitter, right N indicates the collector, central P indicates the base. Now emitter junction is forward biased, so the battery positive is connected to the base and negative is connected to the emitter. Forward bias is reverse biased, collector junction is reverse biased. So positive the battery is connected to collector and negative is connected to the base. So far this is output junction is reverse biased. Here electrons are the majority charge carriers. In NPN transistor, electrons are the majority charge carriers. Now let us study the working of the NPN transistor. Electrons in the emitter are repelled by the negative potential of the bias, emitter bias. Because of the emitter bias, electrons are repelled towards the emitter junction. They cross the emitter junction. A few of them will combine with the holes in the base, constituting base current. Because of the combination of electrons and holes in the base, a current is constituted in the base, that is base current. Majority of the electrons crossing the emitter junction, they will be attracted by the positive bias of the collector. Positive bias of the collector attracts these electrons, so they cross the collector junction and they flow to the positive bias of the collector. The electrons, they cross the collector junction and flow to the positive terminal of the collector bias. So they constitute the current in the collector, that is collector current. the last electrons in the emitter, they will be filled by the electrons from the negative terminal of the emitter bias. From the negative terminal of the emitter bias, electrons will flow into the emitter. The last electrons are being replaced by the negative terminal of this bias. So a current flows in the emitter junction, that is emitter current. So a current flows in the emitter circuit, that is emitter current. Like this, three currents are constituted: emitter current, base current, and collector current. This is how the NPN